Question 5a, so we're asked to do the integral between pi and 0 of cos squared theta d theta and show that it's equal to pi over 2. So I know it's cos squared theta, and I know this is a tricky thing to integrate, so I'm going to look at my double angle expansions and see if I can make this to be something simpler. Now I remember that the cos of 2 theta equals cos squared theta minus sine squared theta, and that can also be written as 2 cos squared theta minus 1. And this gives me the opportunity to rearrange this to take the 1 across and divide by 2 and state that cos squared theta equals a half plus a half cos 2 theta. Taking the 1 across and divided by 2. So I'm going to rewrite this integral as the integral of, instead of cos squared, a half, just a number, plus a half cos 2 theta d theta. And I'm going to integrate this term by term, so I'm going to say this becomes a half theta. Cos integrates to sine, and I'm going to divide by that 2, so plus a quarter sine 2 theta. Close the square brackets between limits of pi and 0. I can just check this by if I differentiate that. Sine differentiates to cos times like power, so I'll get a half cos 2 theta, which is what I want. And if I differentiate that, obviously I'll go back to a half. All good. So now I'm just going to put in my limits. So I'm going to say it's pi over 2 plus a quarter the sine of 2 pi, which is just 0, minus 0 plus 0. I don't really need to worry about 0 going down. I'm a bit careful here putting 0 in. This is sine, and sine of 0 is 0. If it was cos, obviously it wouldn't be 0. So just take a moment just to think that one through. So my final answer equals pi over 2 as required.